Dynamic programming. It is a very important topic, and every programmer should know what is a dynamic programming is. And so, what is a dynamic programming? Dynamic programming is mainly an optimization over plan recursion. It reduces the number of calls in recursion by storing the previous recursion results. For example, few programs like factorials, we need to know the previous result to compute the current result, but how to perform it? Um, Similarly, like recursion has two approaches, one is bottom to top and top to bottom. Dynamic programming has also two approaches, one is tabulation and memorization. Tabulation is bottom up and memorization is top bottom. But how to use them? Let's say a program factorial of x. This is the tabulation approach. Mean we'll start from bottom to up. Mean we need to know for a factorial. Let us consider the factorial is 5. We need to know the factorial for 5. So from 5 is the top. We need to come from bottom. Mean we know that bottom is 0 is always 0 factorial is 1. So I'll create an dp array. So dp equal to, and I fill with -1. See -1, and base condition is we know that factorial of 0 is 1. So now the dp is changed to at 0th position is 1, and for loop starts from 1 to 6. It means 5. 1 2 3 4 5. And in the first iteration, dp of 1 I is dp of I minus 1 into I, means dp of 1 is dp of 0 into 1. Here dp of 0 is 1, so 1 into 1 is 1. And for the next iteration, dp of 2 is dp of 1 into 1. Here dp of 1 is 1, so 1 into 2 is 2, and 2 is stored here. And for the 3, dp of 2 into 3 6, and for the 4, dp of 3 into 4 it's 24, and dp of 5 is dp of 4 into 25 5, and dp of 5 is 120. And as you can see, now dp array is filled with all elements, and we are calculating for fifth one. So here fifth one is 0 1 2 3 4 5. Here 120 is the fifth one. We'll return that. And this is the tabulation approach. And similarly for the memorization, will come from top. Here top is 5. Similarly we will create a dp with initial -1, and we'll use recursion method. If x is 0, we'll return 1, and if not, we'll compute the value of x. We'll store in dp of that particular value, and if our dp of x not equal to -1 means it has some value, so we need to return that value. After executing this, we'll get the same result, and this is our result. And now we'll see one more example with live execution. Now we'll use dp for Fibonacci series. As you know that Fibonacci series is 0 1 1 2 3 5 and so on. And if you want to compute this value, we need the values of previous two indices, and if you want to compute this, we need to know the previous two indices. If you want to compute this, we need to know the few previous two indices. Then we know that this can be solved using dp also. And first we'll create an table. So initially we fill all zeros with for example, I want to compute the value of fifth one. 1 2 3 4 5 and 6. I need to compute the sixth one, so n. So I'll read input from the user int of Now I'll show you once. I'll print dp. I'll run the program. I'll save the program. If I enter 5, sorry, print, I'll save it. I'll run once again. If I enter 5, as you can see, 5 zeros are there, but I want to compute the sixth one, so I'll add n plus 1. I'll run once again and I'll enter 5. As you can see, 6 values with initialize 0. So I know that first two values are 0 and 1 always. So here base condition we know. So I'll directly assign it dp of 0 equal to 0, dp of 1 is 1. Now I'll create a function called fib for filling the values, and I'll give a parameter for suppose n. If n is less than or equal to 1, mean we fill the first two values, so we can directly return that value, return dp of n. If n is greater than 1 means if n is second value, we need to know whether previous values are already executed or not. So if not, we need to compute it. If dp of n minus 1 not equal to 0, mean no. If it's equal to 0, we need to compute that value. dp of n minus 1 is equal to Hypnotic of n minus 1 if dp of n minus 2 is equal to 0, we need to compute the previous second value. Hypnotic of n minus 2. If we have already computed those two values, then we can directly return dp of n minus 1 plus n minus 2. Now I'll print Hypnotic of, I'll execute Hypnotic of n and I'll print dp array. I'll save the program. I'll run once. I'll hit and I'll enter. I'll enter 5. Hit enter. As you can see, 0 1 1 2 3 mean our fifth value is 5, but mean we didn't add it to our array. We directly return the value, so it still has 0 value. We can dp of n equal to dp of
n minus 1
n minus 1
plus
plus dp
dp
of
of n minus 2.
n minus 2.
Now I'll return dp.
Now I'll return dp.
Now I'll
Enough.
save it.
Now I'll save
I'll
it.
execute again.
I'll execute again.
Now I'll enter 5.
Now I'll enter 5. As you can see, uh,
Return 5 and the
it returned
value 5
5
is
and
stored
the
in the
value 5 is stored in the
array 2. But
array 2.
the
But
drawback of
the
using
drawback of
dynamic
using
programming
dynamic
as
programming
you
is,
can see,
as you can see,
storing the
we are storing the
previous iteration value.
previous iteration value.
It takes
So it takes
space for
space
storing the results.
for storing the
So
results.
requires
So it
extra memory
requires
for
an
space.
extra memory for space.
And that's it about
And
dynamic
that's it
programming.
about dynamic programming.
Keep
And
practicing.
keep
If you
practicing.
have any queries
If you have
or
any
you need
queries
any
or
help
you need any
for
help
preparation,
for
there is
preparation,
a
there is
channel
a
link in the
channel link
description.
in the description.
Join the channel
Join the
and
channel
contact with me.
and contact with
And
me.
that's it.
And that's it.
For more
And
videos,
for more videos,
subscribe to the
subscribe
channel.
to the channel.